participar de esta conferencia después de un fin de semana largo. Desde la Facultad de Ciencias Exactas hacemos todo lo posible para acompañar este tipo de actividades que son sumamente importantes, porque son un poco lo que vendrá la formación científica y académica de cada uno de ustedes, incluso en el ejercicio laboral. Así que le voy a dar la palabra, luego de darle la muy bienvenida al doctor Martin Leucker, para que le voy a dar la palabra al profesor Sosa para que los reciba y un poco de contexto a todo esto. Esperemos que lo puedan aprovechar y que tengan todos una excelente jornada. Doctor, you are welcome to the University in Misiones. Bueno, así que muchas gracias a todos.
Buen día a todos, ¿cómo les va? A muchos los conozco, a muchos no, pero ya me van a conocer. We are going to start talking into English because our visitor speak only English and German. So I think not all of you can understand German. So let's start into English. Professor Leucker is our guest today. Please let me read it so I don't forget anything from that. Let me read. One minute, please. Yes. Professor Leucker is Martin Leucker in German. So Professor Leucker is professor at the University of Lu, leading the Institute of Software Engineering and Programming Languages. He holds a doctorate from the Aachen University and has held postdoctoral position in US and Sweden. His research focuses on formal methods in software engineering, including testing, verification, and model checking, with application in medical and automotive safety. He is currently developing methods on AI systems. Professor Leucker, es ist uns eine große Freude, heute die Begrüßung hier in Basados. Bitte, schön.
Ja, vielen Dank to understand me in English. So thank you very much for the invitation or for giving the opportunity to give a presentation here about work that we're doing in Lübeck. So I want to talk about the development of AI-based systems, having in mind that you want to put them on the market in the European Union. So the talk is not so much about AI, it's more about everything around what you have to consider when building AI-based systems. Let me say a short word to myself. So I'm coming from Germany. Germany is one of the countries in Europe. And Lübeck is far in the north. It's close to Hamburg. Maybe Hamburg is more well known than Lübeck. Lübeck is a very small town. It's cute. But anyway, typically not that well known. As mentioned before, I'm heading the Institute for Software Engineering and Programming Languages, meaning that I do foundational research in software engineering and also on how to develop AI-based systems. So one of the new aspects is there is AI and how can we deal with AI-based systems in building systems that we want to put on the market. At the same time, I'm also CEO of the Unitransferklinik Lübeck GmbH. What is that? That's a technology transfer company owned by the university and the university hospital. And there we do applied research. And our main focus is to transfer the research that we do at the university into the market, into concrete products. Good. Langsam. Okay, I try to speak more slowly. All right, yeah. So we try to cover the whole line from foundational research to applications in practice. That is our idea. And to come to today's presentation. I want to talk about legal requirements, especially about the AI Act in Europe that you may have heard of. Yeah, so when you want to make a difference between what is going on in the US and what is going on in Europe, I mean, in simple words, in the US, you can do what you want. You're behaving a little bit like a cowboy, yeah, and while in Europe, we want to organize, we want to regulate everything. Yeah, so that's the difference. And so if you want to develop for the European market, you have to develop the software, you have to develop the AI in such a way that you can get it approved and that you can sell it on the European market. And that means you have to do the software engineering in a different way. You're not only building a system that works, you have to build a system that can provably work. And that is what I want to elaborate on today. So, and I want to talk a little bit about standards and norms and about the core technical methods in computer science, formal methods, that is my field of research, how that can be used to prove correctness, to prove conformance to norms, and in this way also to prove conformance to the legal requirements. And I want to give a very, very brief example of one of the methods. In the last part, we're going very technical. It's about property-directed verification of recurrent neural networks. Just to give you a flavor what kind of research one could do in this area. All right, let me say one word about AI. That's mostly everything I'm going to talk about AI. So when you think about artificial intelligence, in the 90s and so on, we mainly focused on symbolic methods. Yeah, so we did symbolic execution, optimization algorithms, and so on. So AI is done for, I don't know, 40, 50 years, and it has its ups, it's had its downs, and at some point, this part was very important. But then there came the AI winter. Nobody cared about AI. But then some new ideas like deep learning popped up, and that resulted that the field of machine learning got very prominent again, and that is what people work on today. So typically, this is what people mean by AI today, all this kind of machine learning. And we call these sub-symbolic methods, while logical methods that you typically call them symbolic AI methods. And the focus, when we talk about AI today, we're talking about machine learning. When you think about doing research in AI, then the hot topic is to combine these two things, like symbolic and sub-symbolic techniques. In very simple words, in sub-symbolic techniques, you deduce from examples. You have lots of examples, and then you want to derive a general model out of that. In symbolic AI, you have rules, you have formalizations. Yeah? And when you think about when you studied, or maybe you're still studying, then you always need a definition. Yeah? And then you have examples. And when you are in an exam and only present examples, then your professor is not happy about it. Yeah, say, yeah, good that you can give me some examples, but you should give me the precise definition. And in some sense, that is what symbolic AI is about, rules, generalizations. And here we want to learn from examples. Learning from examples is good, but it has some difficulties. Anyway, so we talk about machine learning today and all the stuff that is around that to be able to use it into systems development. So when you study computer science or when you look at computer science, you rarely come into touch with the legal aspects. Yeah, typically, as computer scientists, we don't like to deal with legal stuff. Yeah, we want to program, we want to build systems. But let's forget about all this legal stuff. This is something for administration. Well, that's not completely true. We have to follow the laws, yeah, and we have to build on the work of others, meaning we have to be allowed to use them. We have to deal with copyright laws. We have to deal with licenses. We have to understand that. Now, when we deal, when we build products that deal, for example, with private data, we have to build a system in a very secure way that private data is protected. Yeah, that, I mean, you don't want to build a system leaking all the credit card numbers. That's for sure. But you also don't want to build a system where you can track everybody at every moment in time and see, oh, this guy was there yesterday evening in this bar, and then he went on to that bar, and today he's giving a presentation here. I mean, nobody should know that. So we have to build the systems in the right way. What are the legal aspects from a European perspective that you have to follow? Very recently, the European Union introduced the AI Act. Some years ago, they introduced the GDPR, the General Data Protection Rules. Yeah, so we have strong data protection rules that you have to follow with your programs. Of course, you have to adhere to copyright laws, depending on what kind of system you're building. Let's say you build a system that people are using in a hospital, then it has to respect the labor law as well. Yeah, so depending on where you use your system, different kind of further legal requirements come into play. And when you're building a medical device, and in the European Union, we have the medical device regulatory, and we have to follow what the MDR tells us to do. So there's a bunch of different legal requirements that we kind of have to understand, not fully. I mean, we have to work together with legal people, yeah, from the legal department, but at least we have to understand part of it so that we can build a system that all these kind of laws are respected. There's a bunch of further things that we have in the European Union. There's the Data Act, the Digital Market Acts, a lot of cyber security laws, but especially these two are under big discussion with the US, for example, because many companies from the US offering services in Europe, it's a big burden if they have to follow these kind of laws. And there are some discussions going on the, yeah, probably follow the news. But some people like Elon Musk, they don't want to adhere to these laws. Yeah, and there's big problems. Anyway, I want to mainly focus on the AI Act and the MDR today. AI Act, because we want to build AI-based systems, and MDR, thinking about building medical devices, having AI aspects. Okay, why is there an AI Act at all? So AI has many good advantages, increased efficiency, automation of tasks, improved decision-making, but it is trained from data. And so it depends very much how good is your data. If the data is not well designed, you may have a bias, you may discriminate people. We don't really understand why your system comes to certain kind of conclusions. And in general, we have safety concerns when, or you could have safety concerns when using corresponding AI-based systems. And the AI Act puts legal rules to mitigate these risks. The AI Act is mandatory whenever you develop a system and want to deploy it in the European Union. There are exceptions. When you build military systems, you don't have to follow the AI Act. Yeah, so there are the ethical rules for products, for the market. There are no rules for military. There are also no rules for research and development, which is very important because we want to try out things in research. And when these things are bad, we don't want to use them. When the things are good, we want to use them. So after doing research and we want to put them into the market, then we have to follow the AI Act, but not it does not stop us from doing research. And there is a special thing which is called sandboxing. When transferring ideas from research to practice, there is the so-called sandboxing phase that you can use. And the sandboxing phase basically allows you to try out the AI in a protected environment. So the sequence is research, sandboxing, the market. So how is the AI Act patent? If you develop medical devices, you have an idea how you proceed because it's a risk-based approach. What does it mean? It means that you first think about what could potentially go wrong. And you basically put the system into one of these 4 classes. We have the unacceptable risks that AI-based systems would be put in that class if you violate fundamental rights. Yeah, so personal screening and so on is forbidden in the European Union, and you are not allowed to build any kind of AI system supporting you in that way. Then you have the high-risk class. High risk means the system could induce some kind of health issue, or maybe also go against fundamental rights. Yeah, so if we build a respirator for controlling the what is it called, for your breathing, yeah, then if the system is going wrong, you have a big problem. Yeah, so these are high-risk systems, and there you have to basically test the AI much more than for, let's say, lower-risk systems. There's transparency risks. For example, if you call a company, then often there is a chatbot now rather than a human person, which is fine according to the AI Act if you make that transparent. So you have to tell the user, when you call this number, there won't be a person, it will be a chatbot. Just so that you understand with whom you are talking. These are the transparency risks. And then there are the minimal risk systems. That is like a spam filter, a recommender system, and so on. There you don't have to do a lot. It's just the high risk class that basically requires certain kind of extra treatment. And what do you have to do for the high risk class? You have to do a risk management to identify and mitigate potential risks. You really have to document what could go wrong in your system when this AI is not working fine. You have to deal with data governance to ensure data quality, fairness, and security. Yeah, so you have to think about, is the data really the right data? For example, the typical case is you want to build a system screening the eyes automatically. And then you test it with lots of, or you build it with data from lots of European people. Yeah, but European people have different eyes than the people in India, for example. Yeah, and you cannot use the same system trained with European data in India, for example. And that kind of things you have to understand, and you have to think about these kind of things. You have transparency and explainability, meaning you have to, the user has to understand why the system is acting in that way. Who of you was using ChatGPT already? The others haven't understood me, I guess, right? No, I guess everybody was using ChatGPT, right? Yeah, sure. And you have to understand how ChatGPT works. Yeah, to give an example, I mean, I was asking ChatGPT about my publications. It gave me a nice list of publications that I was the author of. but none of them was correct. Yeah? But if you understand how ChatGPT works, it's clear, because ChatGPT combines things by probability. Yeah, so I don't know, bread is similar to breakfast. So there's some combination, putting words bread and breakfast together. Now, what was ChatGPT doing in my case when I asked about my publications? So ChatGPT knows how a reference to a paper looks like. So it puts some authors, my name, and names from people working in the field. So it understood, I'm working in this area, there are other people working in this area. So a typical reference looks like my name together with other names working in that field. And then it also produced titles in that way. Yeah, so knows what kind of work I'm working on and what other people are working on, and it was combining the titles in that way. So it was an excellent list of papers, and maybe I have to contact the other people and try to work on it. So it could be, but if you understand how the system works, then you can understand any kind of real data. You have to be very, very suspicious. ChatGPT is good for formulating stuff, but not for facts. Facts are made up. This is known as hallucination. Yeah, but it's clear that the system will hallucinate. And if you don't change the working of ChatGPT, it will always hallucinate. Yeah? ChatGPT has to understand, okay, somebody is asking me for a fact. And then I don't try the standard mechanism. I have to Google something like that. Yeah, and then but otherwise, there's no chance to get rid of that. Meaning, you have to explain to the user, and the user has to learn how the system is working to be able to understand, okay, this is a good result, that is a bad result. This is a result where it should be suspicious. And for high-risk systems, there should be human oversight. The final decision is always made by a human. Yeah, you have a doctor, and the AI will help him to get some diagnosis, but the diagnosis should be confirmed by the doctor. You should not trust the AI system completely. And then all these kind of systems have to be secure. Yeah, so if you use them in a malicious way, they should not, for example, provide private data. All right, let's go back to this picture. There is this part. So the AI Act, they worked on it for several years. And then at some point, there came these large language models like ChatGPT. So what kind of system is a large language model? Is it minimal risk, transparency risk, high risk, or unacceptable? Well, it depends on what are you going to use it for. If you use a ChatGPT for chatting in the evening because you're bored, fine. If you use it for diagnosing a patient, then it's a high-risk system. So in some sense, they said, okay, there are these general purpose AI models, and depending on where I'm going to use them, I have to use them in a different way. But if you want to use them, they have to provide technical documentation and user manuals. For open source models, they have to provide open licenses, and they also have to explain with what kind of data the system was trained on. Yeah, so it's fine to use available large language models, but they have to come with corresponding information so that you could do the risk analysis if you want to use them in high-risk systems. All right, the AI Act. So this is a slightly outdated slide. So in the meantime, the AI Act is approved and the adoption is still going on. Yeah, so there's a timeline. Many years ago, they started the discussion about it. And in the meantime, the final decision has been taken, but there's still some time, for example, for certain aspects before they're taken into force. Yeah, but this is a reality right now. And that's kind of the European view on how to deal with AI. There was a similar thing going on in the US. So in the US, they also had similar rules. They started later. And so the European Union started with the AI Act, and then the US also installed certain kind of laws. But since some weeks, they are now completely abolished. Now in the US, you can do again what you want, depending on where you want to apply it. But yeah, if I would have done the presentation end of last year, I would have said there are similar laws in the US. Now, due to some change in the US, there are no such kind of laws anymore. And there are similar laws in China as well, for example. So the AI Act will impact businesses, companies, consumers, and also regulatory bodies. Yeah, so if you work on putting medical devices into the market, you have to check, do they have some AI component? And if yes, you have to follow the AI Act. Otherwise, no chance to get it approved in the European Union. Now, how does it work in general, to give you some background on that? Typically, people have some ideas, politicians have some ideas, and then they design laws. Laws are very abstract. They say, okay, you have to do this, you have to make sure that this does not happen. But how do you do that? Typically, laws are refined by norms. Yeah, for example, if you think about medical devices, there's a bunch of norms, EN 62.304 or EN 82.404, that when you follow these norms, everybody assumes that you follow the law. Yeah, so the law is very abstract, providing general ideas. Norm is more concrete. It's easier to follow a norm than a law. And typically you follow a bunch of norms to satisfy a law. And how do you follow the norm? Well, we as computer scientists, we build tools and design certain methods that we can use the tools, we follow the methods to satisfy what the norms will do, and then adhere to the laws in that way. And that's the same for AI. So there's, for example, the European Union had some expert group discussing about trustworthiness in AI-based systems, and that resulted into standardization efforts. For example, there's ISO, but there's also DIN, probably you've heard of that. These are standard norm bodies that design certain norms. The European Union installed an expert group. They produced ethic guidelines for trustworthy AI. And you see, they said, okay, a trustworthy AI-based system has human agency and oversight, technical robustness and safety, privacy and data governance, transparency, and so on. It's pretty much what you have to follow when building a high-risk system according to the AI Act. Yeah, so it was before producing the law, they hired experts. They came up with a lot of wishful or important things that was turned into the law. And now there are many standardization efforts going on. Just to give you an idea, I think I skipped that slide. There are some existing standards already for AI-based systems, and they're still working on more. Yeah, so there is AI, the technical stuff, but there's a huge work going on just on building norms on how to use these kind of systems. And I don't want to go into details. Now, I told you that in the US, there is no similar thing like the AI Act anymore, but there is something similar like the MDR. So when you have a medical device and you want to sell it on the US market, you have to follow the rules of the FDA. Yeah, so US is FDA, Europe is MDR. China has their own rules, and I don't know about Argentina, to be honest. Yeah, you don't have rules. That's good. It simplifies things. Yeah, it has advantages and disadvantages. Yeah. So in Europe, you spend 50% of the time for developing the system, and 50% of the time for getting it approved. Yeah, so it's a very, very huge effort that we have to spend just to get things on the market. And that's also why it's very good to have ideas, new ideas for new medical devices. But when you develop them, you have to think about all the rules, because otherwise it's very difficult to get them into the market. But the FDA, for example, they also have ideas what you have to do to get AI-based medical devices on the market. So the US stopped general rules about AI, but they put AI-based rules into dedicated norm for special application domains. So my talk was so far mostly about the legal background and how does it work with law, norms, and so on. Now I want to go a little bit more into the computer science aspects. So how could we as computer science not just build AI-based systems, that's one topic, but how can we build tools, methods that help us bringing such systems into the market? So, and I want to just point out some kind of research directions. Risk management. When is somebody mechanical engineer here? No. Okay, so when you build medical devices or cars or whatever, you do a risk management. And the typical method that is used there is FMEA, failure mode and effect analysis. Yeah, so you have dedicated tables, you think about different risks, and you say, okay, for example, when you build a car, yeah, very important for a car are the brakes. If the brakes don't work, you have a problem. Now, how can you mitigate the risk? And the brakes can fail, right? And then you have a problem. How can you mitigate the risk? Well, you put two independent systems for the brakes. If one system fails, you still have the second part of the brakes. Yeah, so typically you have 4 wheels on a car, and 2 brakes work, or one system works for 2 wheels, and another system works for the other 2 wheels. If one system fails, you still have some braking power. And you can do the very same stuff for AI-based system. Yeah, how can you make sure that the data, that the input of your AI-based system fits to the data that the system was trained for? Let's go back to the example. You have the system that was trained with European eyes. Yeah, how can you make sure that the system is not used or does not impose the risk of being misused by people it was not trained for? Well, impose a check that the eyes correspond to the training data. If they don't correspond to the training data, if they are too far away in some kind of metric, then you say, okay, don't use the system. Something like that. Yeah. And there are many standardized ways of thinking about risk for AI-based systems. And one could adapt these methods known from engineering to AI-based systems. That's one way to support this risk management aspect. when we think about data governance, yeah, we can do an online analysis of the data as it described. Yeah, does the data, just described in this example, does the data fit to the training data, for example? Is anonymity, sorry, that's a difficult word for Germans. Anonymity, is it guaranteed? Yeah, or is there personal data in the AI-based system? One can use homomorphic encryption. What is the idea of homomorphic encryption? Well, for some computations, you don't have to understand the data directly. Yeah, so you take the data, you encrypt it, and then you send it to an algorithm. The algorithm computes with it. You send back the result, and then you do the decryption, and then you understand the result. And that is, for example, homomorphic encryption, how to deal with the data. But there's also very simple stuff like having a version number for the data. It's also, I mean, it sounds very simple, but it's often a problem in practice. You have a device, the device is not working correctly, and now you have to understand, yeah, why it's not working correctly. You should know what kind of data was used for training, especially this version. For explainable AI, you may use formalisms that are better to understand, like decision trees. You can develop surrogate models. You have to understand, is the data really real data, or was it generalized, generated data? Are these real pictures, and so on? So we said we want to have that the final decision is taken by a human. So we have medical processes, and we have the concept of workflow systems in which we can model workflows in medical situations. And that way we can make precise who is supposed to do what. And we can check that in the end, the final decision is always made by a human by analyzing such workflows. Yeah, so using techniques like low code, no code, where you develop systems using the workflow methods, you can have steps that are implemented by AI, but at the same time, the complex system is visible to the user, and it can be checked easily that finally a human is taking the last decision. For cyber attacks, one can use general verification techniques, static verification, runtime verification techniques. I don't see a very big difference in verification techniques for such kind of systems. So let me see. Yeah. Here's a picture. Actually, it's in German, it doesn't matter, but that's a well-established software quality norm. And there is no word on AI in this part. Yeah, so this is when you build standard software systems, you have to follow the ISO norm 25010. But there is nothing comparable with AI currently. But it will change in the near future. Maybe you work on quality methods. So how to extend the ISO 25010 by dedicated means for ensuring the quality of AI-based systems. That is what we have to work on now. I want to give a very technical overview about one method so that you can see, okay, so there's a huge range. So there is potential for everybody to work in this field. Lawyers, people who like designing rules, norms, but it's also for people with a strong mathematical background. There is a lot of room for analyzing AI-based systems to make sure that we understand that they are correct. And I want to describe one method that we call property-directed verification of recurrent neural networks. Yeah, and then sorry for being a little bit technical here. So we assume that we have a system that is running, produces a lot of runs. And we have some notion of correctness, and we want to ensure that all of the runs here that they satisfy the correctness property. How can we do that? So we have to solve a subset problem. Well, there is a technique, and that is called model checking. Probably, I don't know, has somebody of you heard about model checking? Yeah. So what is it in a very abstract way? Well, the idea is that we change the runs of our system into some model, incorporating, so all the paths in this graph are all runs of our program. The correctness property is also translated into such a model. Then we combine these two models in the model checking stuff, and then we can analyze this question. That is a method called model checking, was introduced by Emerson and Clark and Kiel and Sifakis. You see 3 pictures, 4 names. Kiel was working on the initial paper in the 80s, but then he left research. And the other 3 guys, they stayed in research, and they got the Turing Award some years ago. And so Turing Award, you know, is kind of the Nobel Prize in computer science. So if you make the Turing Award, then you made it. And you should stay in research, because if your work is very significant, you may eventually get the Turing Award. But if you leave research, like this guy, you don't get it. Yeah, so better to stay in research. Another comment, Clark died of COVID. Yeah, so if some of you are skeptical about COVID, whether it was there or not, there is some evidence that some people died because of it. Yeah, so I think COVID is real. There are always some people that think COVID is not real. Anyway, okay. Now, when we don't have access to the source code, when we don't understand the system, when we want to consider the system as a black box, what can we do? Well, is it real? Yeah, we have legacy system. Code is not open source, third-party software, embedded systems, and so on. We often don't have access to the code. We treat it as a black box. What can we do there? We cannot give the model there. Well, we could learn the model. And then, once learned, we have such a kind of automaton model here on the right-hand side, and then we could do model checking. And how can we do that? Well, there is some technique introduced by Dana Angloin. It's building on ideas of Moore from the 50s, and there are techniques how to learn such a system. There's a communication of the ACM article describing lots of these kind of methods. So in some sense, now we want to apply that for recurrent neural networks. And then we can do the model checking stuff. I don't want to go into detail here, but just to show you the steps. How does it work? So we can understand the system described by the language of the system, by the indicator function telling us when a word is not in the language or whether it's in the language. Yeah, so it's for words it's 1 if it's in the language or not. And the learner is going to learn such a language and eventually produces an automaton model. How does it, when it's done, we can do the model checking. How is it's done? Well, it produces, the learner makes so-called membership queries. It asks the system, is A, B in the language or not? Is that possible or not? Is this picture a cat or not? Something like that. And after makes these queries, puts them into some table. I don't go into details here. But at some point, the table looks nice. We call it coherent. And then it makes an automaton out of that. And then it asks an oracle, the equivalence oracle, and says, look, I've done some investigation. I came up with this automaton. Is that the right one? And then the equivalence oracle either says yes or it says no. If no, it provides a counterexample. Here, obviously, this guy doesn't accept the empty language while BA is in the language. So it will produce a counterexample. Then the learner continues, comes up with a second suggestion, and then the equivalence oracle says, yes, this is the right automaton. So that's kind of this thing we're going to use, because then we could do model checking. Now, how does it work for recurrent neural networks? What is a recurrent neural network? A recurrent neural network is basically a function that takes its state encoding, so it takes a vector of size k over the reals, together with an input vector of a size L over the reals, and produces a new state. We simplify it here that we go from some infinite alphabet to finite alphabet. We change the input, and then we can extend it to words, to sequences. And then we have an indicator function telling us whether the state is accepting or not. And in that way, we get a language. So a recurrent neural network, when you think about it, if you don't know recurrent neural network, just trust me. But if you know recurrent neural networks, think about it, it's basically a language acceptor. And that means we can use all the machinery from formal languages, like model checking and so on, to verify, to analyze such systems. And that's what we're going to do. Problems with battery of the pointer, sorry for that. But what does correctness mean? Do we really want equality? No, we don't want to have equality, because we want to specify in terms of finite automata, while this language acceptor, it has an infinite state space. Finite automaton has a finite state space. So we are more interested in language containment, meaning the recurrent neural network should be different from some negative behavior, or it should include all the positive behavior. And doing some mathematics, we can always encode it as an inclusion problem. So I don't have to look at the details here. So what do we do now in property-directed verification? Well, we take the learner to get a hypothesis. It adheres, the hypothesis has some similarity to the recurrent neural network. Fine. We could do equivalence queries here. That is what Anglian's algorithm would do. But we don't do that. We do the model checking first. So we check whether this hypothesis, this guy that is similar to this R, whether it contains only allowed behavior, whether all of the behavior of this hypothesis is a subset of the allowed behavior. If that is not the case, that means there is some behavior in the hypothesis that is not allowed. Now, maybe it's in the hypothesis, but not in the system. But maybe it is. So let's check it. So we check whether this guy, this W, that is in the hypothesis, but not allowed, whether it's really a potential run of the recurrent neural network. If it is, we have a bug. The recurrent neural network does something which is forbidden. If not, well, it means that the hypothesis does not reflect what R is doing. So we send it back as a counterexample to the learner. The learner then produces a new hypothesis, better one that is closer to R. And maybe the model checking succeeds at the next round. Then we do the inclusion checking, the checking whether this hypothesis is indeed an over-approximation of this R. Yeah, maybe the hypothesis is correct, but it doesn't have any kind of, but it misses certain kind of important behavior of this recurrent neural network. If that is the case, if R is a subset of that, then we are fine. Then we know, okay, R can be abstracted by H, and H satisfies the allowed behavior. If not, well, then there is a run of R that is not in H, meaning we can send that back as a counterexample to the learner, produces a new hypothesis, and eventually comes up with a better result. And we do this check here by statistical testing between two different systems. We've implemented the stuff. It works quite fine. I don't want to go here into the details. I just wanted to give a rough overview that the field of dealing with AI-based system is quite huge, ranges from the legal aspects to, let's say, also technical details. I skipped that one. So what is my conclusion? There is a natural connection between ethics, law, norms, and formal methods. Formal analysis helps to also look at explainability stuff, verification, and so on. For AI, all aspects are addressed partially. A lot of work needs to be done to get a coherent understanding on how to build good AI-based systems. So the software engineering for AI-based systems is a huge field for which a lot of research has to be done, both on technical things, but also supporting the legal aspects. And formal methods are a key ingredient to do so. Thank you for your attention, and I'm happy to receive your questions.
Pero no seas tan... Ahí está llegando. Acá está llegando.
Hello. Yeah.
Okay. With the cost of infrastructure lowering down nowadays, do you think that the AI Act would overlap, like, I don't know, my privacy if I'm running like a local cluster of AI that doesn't adhere to these standards on the AI Act?
So, I mean, first of all, I think it's great that the prices get cheaper there. We have a big discussion in Europe. Could we use ChatGPT? Because could we trust to send our data to third-party companies? And we spend right now a lot of money in building our own infrastructure. And we cannot get the biggest models to run locally. But it would cost, but hopefully we can do it in the near future. And it's also good that, for example, you have DeepSeek, for example, they have smaller models and it's easier to run them locally. And that has a great impact on approving your system according to the AI Act. Yeah, because if you make sure that the data is locally treated, you don't have to understand what an external company is doing. Yeah, so for example, if you think about DeepSeek, I mean, they put their models open source or open weight models. So you can download them, install them in principle on your computer. And so there are some countries that say, okay, you cannot use DeepSeek in the web version, because you send your data to China, we don't want this. But if you take the model and run it locally, no problem. You are in control. Maybe the weights, that's a different story. Maybe the weights in the network, meaning the data is trained on, maybe that's different. It would also be interesting to see how do certain kind of political questions are answered by a US model and by a Chinese model.
Yes, because all of these regulations are easier served on the AI as services. You can audit them, you can look at them, you can test them, but not local. I mean, like, if I have my cluster here running, and I don't know, maybe it doesn't follow the AI Act. And I understand that DeepSeek was banned in several countries. I don't know, Europe, I don't know for how long, or still up to that.
Yeah. No, I mean, it's important to be able to run these systems locally, to have full control. I mean, when I was in Munich, we had projects with BMW, verification on the code. And it is impossible, it's not thinkable that the code that is running in the car is sent to a university. They don't do it. Or if you think that the code is sent to some third party for analysis, they don't do it. Yeah, I mean, this is company secret. It has to run locally. Yeah, so for many projects, we could build systems using ChatGPT or OpenAI in the background, but many companies will just forbid that. Will say no, and that is why we built up our local clusters to run the models locally, so that we can say, okay, you give the data to us as university. We are trustful, hopefully, and then we can analyze your system, and then, but not to some third-party company. It's too much business risk.
What's your involvement in the automotive industry? I know that AI is being used for, like, I don't know, when the driver is tired or is angry, like facial recognition, like pedestrian recognition for autonomous driving. I don't know what other things are integrating AI into the automotive industry.
I mean, I'm not working on the automotive stuff right now. When I was in Munich, we had collaborations with the automotive industry. It's in the south of Germany, BMW, Mercedes, and so on. In the north, there's more medical technology. And so we do projects with medical technology. We're working on diagnosis routines based on formalization of medical data, trying to understand what symptoms are there and what would be the diagnosis for the patient. And we do small optimizations in medical devices. For example, when you think about the respirator, it's very hard to put the right values so that it's optimal for the patient. And it would be very interesting. So you have the experienced doctors, they know how to install the machine in the right way. It would be very interesting to have an AI that could assist a nurse and say, yeah, I do the treatment of the configuration of the system automatically, something like that. These are the things. Also partially supporting operations by robots. So, but it's also not fully automatic operations, but it's manually. So there are doctors using robots to do operations, but then doctors can do some mistakes. So the AI should check whether what the doctor is doing, whether it makes sense or not. These are the things that we're working on right now.
Thank you.
Hi, sir. Good morning. You said the AI, the human have the final decision of AI. How do we explain that to the user or the people or people who knows or who think the AI have all the control? And we have to develop or build AI and explain that, and we have to show the algorithms or what we have to do to explain the user.
Very good question. Short answer, I have no idea. Now, more long answer, I mean, this overlaps with computer science and social science. Yeah, so it's very hard to understand what should you do to convince a user. I mean, you have the doctor, and you can build a system that the doctor, for example, think about analyzing radiology images. Yeah, so yeah, you have to look at the image and say, okay, there could be some kind of cancer stuff in there. Now, one analysis could be done by the system, and the second analysis by the doctor. And then you check whether they find the same problems. And now you can design the system in two different ways. he can first let the AI run and then show it to the doctor. And then the doctor can double check and say, okay, the AI was finding all these things. But there you might say, well, then the doctor is lazy and it checks, yeah, looks good, fine. Now, if you design the system in the way that you independently, the AI is evaluating the picture and then the doctor gets the results of both of them and see, look, you found this, the AI didn't find that. You and the AI found these 5 things and you didn't find them. Then you have a much higher security that you really find the right spots. And that's more from the, let's say, easy kind of workflow that we as computer scientists understand. Now, that I can explain to a doctor, and I think the doctor will understand what is the difference. On the other hand, you have the patient. Now, the patient goes to the doctor knowing that the doctor is doing some work and the AI is doing some work. And you want to make sure that the patient also understands that he or she is treated well, even if the AI is part of that. But I don't know patients too well. I don't know social science too good to understand what should we do to make, let's say, the general public understand what's going on. So I think there is a lot of room for research, also for social science, but it's outside of the area of my expertise.
Thank you.
Hi. I have 2 questions. The first one is, you said that a system that has an AI component has to be included in the limits of this kind of rules, laws or anything.
Yeah.
What is the definition of an AI component? Because I was thinking, if the development team use AI in some parts of the development process, technically there is AI in there, including or not an AI component itself in the system. The definition in that case?
Again, a very good question. So there are several problems with the AI Act. There is no precise definition what an AI component is. There is no precise definition what AI is. I mean, what is intelligence? So is my program that I programmed as a programmer using logical methods? You can also say this is AI, but you can say, no, it's... So the AI Act tries to focus on machine learning, but it's not really well defined. So you can say every kind of program has to be considered under the AI Act. What was perhaps not the intention of the AI Act, but there is a clear definition missing. Then, so I would say from a practical point of view, you would say if you use machine learning, and that could be for any part of the overall system, but that is what you do the risk analysis for. So for example, if you build a car and you say, I want to do automatic driving based on AI, then this is a high-risk system because the car could kill people. Now, if you say, okay, I built a conventional car, but I use AI for choosing the best radio station according to what the driver typically listens to, yeah, or if you use Spotify in the car, you also use AI, yeah. But there you would say, okay, what is the risk of getting the wrong song? I mean, it's not a security problem, or it's not a safety problem. So that would be low risk, and then you don't have to do anything. Yeah, but you have to think about it. Do I use AI in my system? And what is the risk for the overall part? And that is, I think, maybe the way you should treat it. And then, of course, you can also say, okay, I don't know what system I'm using. I hide that I'm using AI. And then you also follow the AI Act because you don't have it in. But there is, formally there's no clear definition. So it's one of the laws where I'm pretty sure that in 2-3 years we will have an update where all the experience is included in making the law more precise. And we're also, the courts have to give a lot of evidence what was really meant by that.
And I thinking of on something not maybe not medical, maybe something simpler like a virtual assistant for, I don't know, students to accomplish some task in an office in the faculty. In that case, if we build an AI agent, maybe we are going to train with some documents or some data. After deployed, we need to monitor the answers. We need to monitor the inputs, and the act is going to, it's planned to specify a time window in which we need to analyze that and retrain the agent, or when we have to, I don't know, maybe shut it down because the answers are going below some threshold or something like that.
I would, I mean, one has to look at the details, but I would say that probably the AI Act is not applicable here because, I mean, what is the risk for such a system? Yeah, I mean, the risk is that the students get the wrong answers or not trained in the best way, but it's not really a safety problem. Yeah, so I would say this is a low risk system, and then you don't have to follow the AI Act at all. It's more like if you use it for publishing news, or if you, I mean, it depends. Again, I mean, if you use it for training the whole world, and then train the world in the wrong way, in wrong methods and so on, and that may have a big effect. Yeah, so I don't know, when your system is training the world and explaining that some COVID does not exist, then it potentially becomes more risky, and then you have to do more stuff. But if it's, let's say, the standard exercises of your course, you might have the problem that your students are not well educated, but that's not the problem of the AI Act. Yeah. It's a problem of your university. Yeah, I mean, you want to, in the low risk situation, you still want to have a good product, right? So you still have to think about measures. How do I make sure that my system that I want to develop for the university, let's say, is of good quality, but it's not enforced by law. This is more like your business model that tells you, yeah, I should double check that the system is really a good stuff, that the students are happy, and so on.
What do you think about AI taking over people's job? It's a shocking question, but
That's a good question again. I mean, I think it will happen. Yeah, and I think it will not happen in the way that it's taking over the jobs directly and in some sense, but it's more like, I mean, I'm using AI as my assistant. I have a secretary and I have my AI assistants. And sometimes the AI assistants are faster than my secretary. And so I think a lot of things can be improved using AI technology, I mean, made faster, digitalized and so on. And that will reduce the number of jobs, for sure. In Europe, we don't have enough people working. So in Europe, it's right now we are on the safe side. Yeah, so everybody thinks it's great. We don't have enough workers. So it's good that we have AI helping us out, improving our efficiency. But of course, I mean, in societies where you have a lot of workers, where you have a lot of unemployment, it could also be a problem. And that is only, I mean, right now we use mainly AI for, let's say, intellectual tasks. But if you think about robots doing physical tasks that are trained using the newer AI technologies, then it could also mean that we need less workers. I think it's a serious problem.
Someone more organized. You talked about the ISO, the 25010. You said that in the future it could be expanded to contemplate AI definitions and things. Do you think that with this being like a whole new paradigm, we should expand like the 25010 and the 25012, for example, data, or that we should like create a new standard for this?
I don't know. I mean, right now what's happening is that new standards are developed and concentrating about data and AI. I have a problem with too many standards. Yeah, so I mean, what's the idea of a standard? The idea of a standard is that all people adhere to the standard. If you have 100 standards, then you basically don't have any. Yeah, so if everybody can do, I follow this one, you follow that one, then it doesn't match again. So, but I think it's a natural way of evolving in the way that you first produce a new norm and then say, okay, we have that one, and then when we have that one, maybe we should integrate them. So I think the next steps are dedicated norms for AI-based systems, ignoring something like ISO 25010. But eventually, I think the best way would be that these norms are combined, and then you can say, okay, this part, I mean, that's also, traditionally, I'm a software engineer. I'm not an AI person. When I talk to the AI people, they only think about machine learning. But for me, the machine learning is just one part of the big system. Yeah, it's not, so we have to make sure that this AI component is fine, okay, but it also has to be fine in combination with the rest of the system. So we have other quality norms for software development, and I think they have to be aligned at some point so that you can combine the systems in a much nicer manner.
Okay. Thanks.
No? I have one.
Perfect.
You have told us about the exact methods. We know like sharp or lime or gradient. All these methods need to access to the model. But at the last one, you talked about try to predict the model when it's the black box and you don't know the model. And even when you compare the input versus output, and you can access to the model, and you have different values like the weights in the neuronal network, and can give you different outputs in these terms. And it's a statistic probability that you fault. In the case that system for high risk, maybe we must to use just open source models for apply that this kind of side methods. I know we build software and we want to buy them, but in this case, it's very important to access to this model. What do you think about this?
No, I fully agree. Yeah. So, I mean, that was shown, just showed one method, and what was the idea of this method besides the technical details. So we have a lot of body of work in formal verification of programs, software programs. And now there's the new AI stuff. And the question that we try to follow here is, can we take over the methods, or can we make use of the methods for program verification also for AI-based systems. And in that way, that was kind of the meta idea here. So we take a recurrent neural network as a black box, meaning we only have access to input-output. I mean, we have some access to the system, but we don't know the weights internally and so on. And then we learn a model that we also know how to deal with in program verification. And then we can take over the methods for program verification. I agree that if you understand the mathematics of the model, I mean, of the network, by looking at the weights and so on, you could do a much better analysis. I fully agree, yeah. And so, but then it depends on what is your aim, yeah? So what is the risk level again, yeah? How much effort do you want to spend on the verification? And how much, so this method that I presented, since it's a program verification method, you can easily combine the AI with a program, yeah? And then you can use the same method, for example. In that case, this one is okay. In other situations, you really have to understand the details of the model. There are also techniques for that. I just want to give you one example here. Yeah, but it's definitely not the only one and the best.
Okay. Thank you.
Last, I want to take some works to suggest our students to afford learning English. You have to manage everything in English. Nevertheless, if we don't have any more experience in the university. At the university, you are not going to get English lesson. It's up to you to learn. It's up to you to understand. It's up to you to talk. So, you have to afford yourself in that sense. En español sería, hay que estudiar inglés, sí o sí. O sea, lo mejor que pueden hacer como estudiantes para poder seguir investigaciones, para poder seguir proyectos, es practicar su inglés. Como estudiantes, digo. Después de viejo uno ya maneja cierto inglés. Pero ustedes que tienen toda la oportunidad de avanzar en esto, úsenla. Gracias por la presencia. Let's take a picture.